This is Nick from Scholarly Supplements here, and today I have a challenging tangent line problem for all of you out there. The problem is, a line passes through the point -2, 0 and is tangent to the function y equals the square root of x. What is the equation of the line? So go ahead and pause the video and give this one a try, and when you are ready, stick around to see the solution. Okay, so to start this problem off, the first thing we should probably do is write the point-slope form of the equation of a line, and that is given as y minus y1 is equal to m, where m is the slope, times x minus x1. Here, m is the slope, and x1 and y1 represent the coordinates of a point along this blue line. Here, because this blue line is known to go through the point -2, 0 per the problem prompt, we can use that for x1 and y1. So subbing those in, we get y minus 0 is equal to m times x minus a -2. And then simplifying further, we get that y is equal to m times x plus 2. Okay, so at this point, we have a general form for the equation of our line. The only thing we need now is to figure out the slope. So looking at our drawing here, we recognize that this blue line has a particular slope, and because it is tangent to our red curve here at whatever this point of tangency is, keep in mind, we do not know what this point of tangency is yet, but we're going to figure it out. We know that if we represent this as x comma y, we can set the slope of this blue line equal to the derivative of our red function here, which is y equals the square root of x at this point, x comma y. So here's how you do that. First, writing the slope relationship, you get that m, the slope, is equal to the rise over the run, which is y minus 0, because the y-coordinate of this point is 0, over x minus a -2. And simplifying, we get that y over x plus 2 is our slope. Okay, now we work this out from the derivative. So to take the derivative, we can rewrite our original function, y equals the square root of x, as y equals x to the 1/2 power. Then, using the power rule, we can say that y prime is equal to 1/2 x to the -1/2. And then rewriting this, we get that y prime is equal to 1 over 2 root x. Recognizing that the derivative at our point of tangency and the slope of our blue line must be equal for this line to work out, we can set our slope, y over x plus 2, equal to our derivative, 1 over 2 root x. So y over x plus 2 is equal to 1 over 2 root x. Here, you'll recognize we now have one equation, but we have two unknowns. So we need to figure out a way to find another relationship between x and y. But that relationship was already given to us. That was y equals the square root of x. So now we can make the substitution of the square root of x in for y right here. So if you do this, you get that the square root of x over x plus 2 is equal to 1 over 2 root x. And then cross multiplying, you can rewrite this as 2x equals x plus 2. Solving, you get that x is equal to 2. So at this point, we know what the x-coordinate of our point of tangency is. It's x equals 2. Therefore, we can plug x equals 2 into our red function here, y equals the square root of x, and figure out what y is. So y is going to equal the square root of 2, right? so the square root of 2. Finally, we can use either this equation or our derivative equation to figure out what our slope is. It's not going to matter which. Either way you do it, you should get the same thing. So I'll go ahead and just do it the derivative way. So y prime is equal to 1 over 2 root x. And then substituting in 2, you get 1 over 2 root 2. Then we can use this slope in for m in our original equation. And if you do this, you get y equals 1 over 2 root 2 times x plus 2. Then simplifying this, you get y equals x over 2 root 2 plus 1 over root 2. And this is our answer. Alright guys, I hope you found this problem challenging and helpful. If you have any questions or topics you would like me to cover, please leave a comment below or message me on Twitter. If you enjoyed the video, please consider liking the video and subscribing as it really helps out the channel. Thanks again for watching and have a great day.